All right, this is Mr. Wyrick, and we're going to go over this Chapter 5 review today. Couple of things. You will have a cheat sheet. I'll try to make sure that before the class is up, we get a look at what that's going to be. But just understand that you will have one. You'll get to see it, and you'll have that for the test. So first off, I just want to talk about these on the front just a little bit at a time. The altitude goes from a vertex to the side at a 90-degree angle. It won't necessarily cut the side into any equal parts, anything like that. No proportional parts necessarily. But what it will do is it might end up outside the triangle. So DE on this first one is my altitude. On the second triangle here, IK should be my altitude. Goes from the vertex to the side, 90-degree angle. On the third triangle, IN is, and you can see from this dashed line here that it's going to be on the outside. On the next one, it should be CG as my altitude. And then on this last one down here, it should be PW. Okay, so the altitude, again, 90 degrees from that side. It might be outside the triangle. A couple of those are. The median is going to be a line that goes from the vertex to a side, and it goes to the midpoint of that side. So AB is going to be my median on the first one. HJ is going to be my median on that second triangle. On the third triangle, the median here is going to be GK. It's kind of hard to find with all of the lines through the middle of that one. The median on the next one should be BE. And then the median on the last one here should be TQ. So again, it goes from a vertex to a midpoint of a side. It doesn't always go at that perpendicular angle. It's just going to get there. The perpendicular bisector is going to be one that cuts the side in half, and it's going to do it at a 90-degree angle. So GB on the first one, JM on the second, LM on the third one. On the fourth one, we're looking at DE. And again, it goes through a weird spot. It's not going to go through the vertex. It may not even be close to the vertex. It's just perpendicular to the side, cuts the side into two equal parts. VS on that very last one. And then the angle bisector. With all these other lines, it may be difficult for you to find the angle bisector, so you really just have to look for these little indications that those two angles are going to be the same. So CF is my angle bisector on the very first one. After that, GL. After that, we're looking at HJ. On this one, we're looking at AD for my angle bisector. And then on the very last one, the angle bisector is going to be an RU. Okay? If you do end up with some of these on the test, again, there'll be a cheat sheet, a reference document that you can use to kind of try to find what it is that you're looking for, and you can get to where you need to get. On the next page, I'm not necessarily going to work all of these. I'm just going to say a couple things about them. I will post the key. On this one, it says it's an angle bisector. We have the two angles that are going to be the same, and it's asking about the measure of those two angles. Just 7x plus 4 is equal to 8x minus 1. Okay, so they're equal. If we have this, though, here's the measure of angle 2, that's this angle, then here's the measure of angle GEF. That's the whole thing. So we're going to have to take the one that's the half, the bisected part of that angle, and double it. So we end up with this one doubled. We distribute that to, that's 10x minus 4, and it's just equal to the other part, the 8x plus 8. Okay? Again, I'll go through, I'll solve them, I'll post what it looks like solved. This is the important part of this, is understanding when to double it and when to not. All right? The perpendicular bisector here on this one means that the two sides are going to be the same. But again, you have to pay attention. This one's got JI which JI is the whole thing, and it's got SI, which is 1/2. I'm going to have to double the half. So x plus 8 is equal to 2x minus 2. On number 4, it's the altitude, and it says the measure of ADB. We know about the altitude. It comes to a 90-degree angle, so this is just 6x minus 6 is equal to 90. On the median cuts the line in half. It cuts the side in half. The only thing you have to be careful, well, we'll get to them. On this one, so we've got XU and XV. That's the two parts. So they should be equal to one another. X is equal to 2x minus 8. On number 6, again, the median. It's got UV, so that's the whole thing. It's got IV, that's a half. We have to double this one. X plus 2 is equal to a -4 plus 2x. Okay. On number 7, this is the ones you really have to look out for. I'm pretty sure this information is on your cheat sheet. If you have the intersection of medians, it's where it forms the 1/3, 2/3 ratio. So on number 7, IW is 5 plus x. That's the whole thing. SW, coming from the side, is where we have the 1/3. So we're actually going to have to triple this one. We distribute that 3. 5 plus x for IW is equal to a -3 plus 3x. Okay, and again, I'll go through, I'll solve them. Number 8, find x if EX. Again, here's my median. The one coming from the vertex right here is 2/3 of the entire measurement. The one that goes to the side is 1/3 of my entire measurement. So to get 1/3 to equal 2/3, I just have to multiply it by 2. EX is going to be 2x plus 2. That's my 2/3 side. So I just leave it. My 1/3 side, I'm going to multiply by 2. So that's going to be equal to 4x minus 4. Okay? 1/3 times 2 makes 2/3. So you take the 1/3 side, you multiply it by 2, you distribute that 2, and you can come up with your answers. GV is 21. I'm just going to cut that into thirds. That gives me 7 because it was the whole thing. So that means from A to V here is 1/3, that's 7. From G to A is the other 2/3, that's 14. The whole thing adds up to 21. If AW is 5, that's my 1/3. So my 2/3, my AH is double that, that's 10. My WH, the whole thing, is 3/3, so it's 15. And then they give me FA equals 12. That's 2/3. So if I've got 12 for 2/3, I can cut that in half. Each one will be 1/3, which means my AU, my 1/3, is going to be 6. Same as half of that 12. The whole thing should be 18. All right? On the next page, put the sides in order from shortest to longest. Across from the smallest angle is the smallest side. Across from the largest angle is the largest side. So here's my smallest angle. It's 10. It's on F. So just use the other two letters. ED is my smallest side. 62 is my next biggest angle. So that's EF or FE. And then the largest one is across from the 108. That's going to be DF. Same thing here. It should be BC, then AC, then AB. Okay? We go in the order of the angles, but we go across from those angles. So if you think of the angle as having a letter, then across from that letter is where you're looking. Okay? 48 is the smallest one, so AB. 62 after that, so AC. And then 70, so BC. All right, again, you can draw a line. From 48 over here, that's AB. From 62 down here, that's AC. From 70, I go out like this, that's BC. Put the angles in order. It's the same thing, just the opposite direction. From 5 down here, it's going to be angle C. then 7, which comes down to angle A, then 9, which comes to angle B. I'll go ahead and finish this out later. Describe the Hinge theorem. That's funny, this theorem should actually be over here. So describe the Hinge theorem. If you have two sides in two different triangles that are going to be the same, we can pretend like this is the hinge of a door frame and we're opening that door frame. So if this is 60 degrees and this is 110 degrees, then the distance between is going to be larger according to that. Okay? The wider we open up those doors, the further the distance is going to be between them. The converse to the Hinge theorem is exactly the same thing. It's just instead of angle measures, we talk about side measures. So if this opens up to a 5, and then this one opens up to, like, say, a 10, then this is going to be a larger angle because of the way that works. Okay? So the Hinge theorem says if we open it to a greater angle, we are going to have a greater side. The converse to the Hinge theorem says if it opens up to a greater side, it's going to be a greater angle. The exterior angle inequality theorem, it says this. Here's angle 1, here's angle 2, here's angle 3, here's angle 4. We already talked about on like the previous test. If you take angle 1 and add it to angle 2, it equals angle 4. So the inequality theorem just means angle 4 is going to be bigger than angle 2, and angle 4 is going to be bigger than angle 1, and we know that because they have to add together to make it. Okay? Whatever they are, even if we don't have numbers for them, if they have to add together to make something, each part is going to be smaller than the whole thing. The triangle inequality theorem, again, this word theorem should be kind of over on this side. The triangle inequality theorem is if you have a triangle like this, and we have side A, side B, and side C, A plus B has to be bigger than C. Okay? B plus A has to be bigger than C. I already said that. B plus C has to be bigger than A. And C plus A has to be bigger than B. I guess, yeah. Okay? So any two sides has to be bigger than the third one, or you can't make a triangle with them. Like there will be overlap, there will be parts sticking out. It physically won't work. Okay? And last page. Find the possible values for the measure of angle 1. Here's a 62. We're going to add something to it. We don't know. So angle 1 is going to be larger than 62. That's what we know. Here's this angle. This one plus this one would make angle 1. So angle 1 is going to be larger than 74 in this case. In the last one, you've probably guessed the pattern by now. Angle 1 is going to be greater than 56. What's the relationship of the following? RS and QS. Okay? What we've got here is some sides like that should be the same if we're doing the Hinge theorem here. With RS, we're looking at this angle T and how it opens up. And with QS, again, we're kind of looking at how the whole thing comes together. We've got different sides on there, so I don't know if this is really, I don't know if that's the right letters. We can definitely assume that QS is going to be larger than RS. Okay, same kind of thing with the next one. If we're looking at this though, this is that converse of the Hinge theorem. If we know that the measure of angle A, that'd be this one right here, is larger than the measure of angle D, what's the relationship between BC and EF? That would be that BC is going to be larger than EF. This is a more traditional Hinge theorem kind of question here. Down here at the bottom, again, we've got the angles marked. So we've got sides that we know are 10. We got one side that's the same, we got a second side that's the same. This one opens up to 30, this one only opens up to 20. So DC is going to be larger than AD. With this one here, this is the converse. We've got these 8 sides that are the same. We've got this central side that'll equal itself. Angle 1 opens up to a side that's 15. Angle 2 opens up to a side that's 13. So that means that angle 1 is going to be larger than angle 2. Okay? That's pretty much everything that's going to appear on the test. Again, like the front page, the perpendicular bisectors, the altitudes, the medians, the angle bisectors, that's the stuff that's going to be on your cheat sheet. The cheat sheet this time is just going to be stapled to the test, so that information will be there. We'll be on a Scantron this time again. So other than that, good luck on the test.